Hello, this is Jens from SecurityValley, and welcome to another write-up or related to the SecurityValley CTF. And this time I want to talk with you about the Forgotten License Key Challenge, which is related to the reverse engineering category. So therefore, as usual, I'm logged into ctf.securityvalley.org, have set the category filter here to reversing. And then we can start by click here on open to the forgotten license key and see what challenge we are facing here. So we see, unfortunately, I forgot my license key. Fortunately, the program is somewhat chatty, and maybe together we can manage to recover the license key. Can you help me? So if you click on the link, you will probably end up here, or hopefully end up on GitHub, and you can download here the file, either a pre-compiled ELF for Linux or a version for Windows. But I will focus here on the ELF binary. So therefore, what I've prepared so far is that I have loaded the binary here into IDA, and IDA has done the first analyze here. And we need that in a couple of minutes, but let's first start here by see what we or what the program expects from us. So let's run the ELF here, and we see at least here's one flag required. So we want to have the key and the key of the wrong length. So this is one of the most, or the first thing that we need to find out what is the expected length. We can easily do that by, I don't know, write a script brute force here, or we can try to find the specific length what is expected here with either or with some other things. So let's see what other information we see from the binary. With file we see it's a 64-bit executable. It's dynamic linked, and it's most probably an indicator that it's built with Go, and that we're facing here something which originally was written with Golang. So, and then we can see with the strings command on the license file, if you maybe see something that has to do with the length. So see if we see something with length. This is most probably from the standard binary, and we see a wrong length, but I don't see what the specific length is. So therefore, I would say we jump into IDA, and the first thing that we need to find is the main function, which is here, and which is the part where the program is starting. And I have zoom up a little bit here, or zoom in, and what we see here is this is something like the runtime initialization stuff, and we see go pkg, which is indicator that here a third-party library is loading. So let me quickly search for the package, and let's accept some cookies and switch the browser here. And you see this is an official Go package which supports kind of command line flags or arguments, which suits perfect to the key that we have seen so far after the program start. So that means that we load here, and most probably we see here a compare to 9, and if J and Z was jump not 0, so which means if we have not the expected length of 9 here, the program will exit. So what I'm like to do in IDA is sometimes to replace some addresses, some names with names that I can better remember, and sometimes add some notes. So here, let's say print wrong length so that we can rename the function and add a comment here. So if the length is not mine, then exit. So we can simply verify that by get back here the terminal. It's cleared a little bit. And then back the license key and add 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we see, okay, our first assumption here with the length was totally correct. And then we see, okay, that the program here is a little bit chatty. That I think was a hint that we have seen in the challenge description, and we see that on position 4. So this is a thing that we need to figure out if it starts here counting by 0, or so that it means position where the 4 here is, or the 5. But let's try to replace number 5 by the dash. And we see, okay, and then on position 7, which is 5, no, which is 6 and 7 here, and most probably position 8 is 0 here. Oh, this was wrong. Then maybe the 0 here, the 7 here. Ah, I see what I'm done wrong here. Sorry. Sometimes you need to read a little bit slower. And we need number 7 here. So, and then a D at position 6. So then we see the next message that the checksum for the first license key block is invalid or failed. So I think we should try to figure out what is the expected checksum, and if there maybe is a other mechanic or another function that checks let's call it the second block here from the license. So therefore, let's go a little bit forward here and zoom out a little bit, and we see here validate license. So let's also rename it validate license and jump in the function. And the first thing that come here right into my eyes is the hint with the dash at position 4, which we have already covered. Then the 7 at position 0, and the char D at position 6. So most probably we have ended up here, which means let's rename it here wrong CK sum for first block, and you see we end up here with the message of checksum for first license block failed. So what we see here is an addition. So, and something that is compared to 102 in hexadecimal, and by press H we see the number in decimal. It's 258, and it looks like that the first 4 chars gets added, and then they must hit 258. So how to proceed? Let's say well, let's spin up a little bit of Python for that and write a little bit of code. So I have prepared a little bit, and let me simply create here a new file. Let's call it the helper or the checksum.py, and this time let's go here with the S code, and let me move it here. Okay. Why the heck? Just give me a second. Okay. So here we go. So what we want to do, is quickly do some permutations until we hit 258. So therefore, let's, from the iteration tools in Python, let's import the permutations here. And then I have prepared a function here, which is called the getChecksum. I will explain in a few seconds what the function is doing. Then we have a checksum of the first block. Then we have the pattern of the first block, which was starting with the 7, and we need to find 3 other characters, which will end up, or which will let the first block end up in the checksum of 258. And most probably, let's add this function here. And I will explain a little bit what the code here is doing, and I've forgotten to declare A here, and let's print A. So the first thing here with the getChecksum, which is quite easy, we give the block here as I, which is most probably the length from all the characters that needs to calculate. And the expected checksum, which is here 258, and the function will add all the characters together and then simply check if S here matches the expected checksum, and then we get a true as response. And if that is here true, then we say, okay, A is the first block that we have figured out so far. And then we want to print it. So, but therefore, let's do it here in the right format. And say here is A. And then C. Oh, this is the wrong terminal. So let's say here with Python the checksum, and yeah, I've forgotten something. What I've forgotten. What? Ah, yes. I'm sorry. So, and then we have 701J followed by the dash, which we don't need at the moment. So let's use that and get rid of the first characters here. And what we now expect is that we don't see the message that the checksum of the first license block failed. And we see that now the checksum for the second license block is also invalid. So that means we can try to find with the same mechanic characters that fits or that matches the expected checksum. So with that in mind, let's follow here a little bit the control flow. And this is most probably runtime. So Go is runtime, or in every Go binary we have to Go runtime included. And this is most probably something like checking if an array, or precisely a slice, is out of range. So that is a good indicator that we have here a loop which picks every block or every char from the input license and iterate and try to do some calculations and comparison on this. And this is most probably straightforward. We have add here and add here. And from what we see here so far, we can assume that the final compare here is 11AH in hex, so 282, which is most probably the checksum of the second block. What all the commands here do in detail, it's really out of the scope of the video. So therefore, let's say we have here the second block. So let's edit here. Then let's add the format string. Then let's define B here. And simply do the same here, and this time we want to format it with B, and we have D here as the first hint that we got from the program. And then let's see if we got a license key here. Let's copy that, use the key, and at least we see no error messages related to the license key format and the checksum anymore. So that means we have, let's say, passed stage 1 and 2, and we now need to find the key that the output here looks more or less like something familiar, maybe the SecurityValley flag format or so. We need to find that out. But some closing words here to the Python script to introduce this here a little bit. So the permutations create from the range of hex 30 to hex 7a, which is more or less, if you look on an ASCII table, let me make this a little bit bigger so that you can see that better, which starts here, so with the number 0, and end up here with the number with the character Z or Z. And yeah, you can simply kind of ignore here the first stuff, and my assumption here was to not include some special characters, and also don't use here some braces or a pipe symbol, but you can for sure easily include that in your script or in your test script. And from that endpoint, we want to see every combination with the length of 3. And therefore, we brute force here simply until we hit the expected checksum. And I think with 3, with a possible, or with a length of 3, that take not that much time, as you have seen here. So I would say we make here a short break, and then we're going to see what's happened, or what we need to do to maybe guess or brute force the right output in the second part of the video. So thanks for watching. See you in the next video.